Welcome to Chillin' 101. We hope this video helps.
You start by confirming hardware and permissions so development isn't blocked. Connect an IR-capable camera, EMU, and a compute unit with GPU or NPU, then install Python and OpenCV so you can prototype quickly. Once done, add a DNN runtime and sensor drivers so inputs stream reliably. Also prepare a labeled dataset and test consents. You need annotated examples for training. Make sure to verify USB and power stability now, because unreliable capture ruins later steps. You now build and combine models. Train a robust face detector, a gaze estimator, and a head pose network using transfer learning to save time. Then integrate sensor streams by synchronizing timestamps and calibrating the IMU to the camera so estimates are spatially consistent. Once the pipeline is functionally correct, optimize models for your edge unit through quantization and pruning, and deploy them into a real-time loop to keep latency low. This is where system performance meets user safety. You finish by defining driver state logic and alert thresholds so the system makes clear decisions. Next, run in-vehicle trials recording latency, detection rate, and false alarm counts, then iterate thresholds to balance sensitivity and nuisance alerts. Make sure to add fail-safes and a quiet fallback mode, and enable OTA updates plus privacy controls for enrolled users. If the system misbehaves, check camera calibration and timestamp sync first. These are common root causes that explain.
Thanks for watching. Consider subscribing if we helped you.